Welcome to your notes for Dilations 12-7. Pardon the hat and the hair, it's crazy hat day. So dilations you've been doing since you were in the 6th grade. They're images used on a coordinate plane or off a coordinate plane, and they're a form of transformation. Basic definition of a dilation is an image that is similar but a change in size. Congruent is same size, same shape, whereas a dilation is the same shape but different sizes. A dilation can either grow your image or shrink your image. One of the dilations we're most familiar with is when they dilate your eyes. When you go to the eye doctor where they put drops, you make your pupils get really big so that the doctor can see into your eyes. You can also sit with a friend or a family member and turn off the lights and then have somebody quickly turn them on, and when you're staring at each other's eyes, you'll watch your eye pupils get really big and really small based on the light. They get really small to keep light from coming in, and then they get really big to let more light in so you can see when it's dark. So that's dilation. So when you're looking at an image, well, that marker doesn't work. Okay, if you have this shape and then you have this shape, those are a dilation of each other, okay? And you have what's called the image and the pre-image. The pre-image being the first one, and then the image being after you've dilated it, okay? So then, a couple things you need to know is when you've done this before, you just had the images. Now we're actually going to have a point of dilation, or a center point. I'm going to read the textbook definition to you, and then I'm going to explain it because this definition is really crazy and hard to understand. Okay? A dilation is a transformation in which the lines connecting every point P with its image P prime all intersect at point C, called the center of dilation. Alright, everybody looks at that definition and goes, what in the world did you just say? So, for example, if we have the line PQ, okay, and we're going to dilate it based on whatever our scale factor is. That's not important what it is now. Okay? And this is P prime, and this is Q prime. Okay? The point of dilation is where these lines intersect, okay? Where all the points. So, if I were to take, and I drop my ruler, pardon me. Found it. Sorry about that. You would take a ruler and connect these points and keep going. Need a longer ruler. All the way out, okay? And you do the same thing with these points. The point where they all intersect is your center of the dilation. Okay? Where you could connect all the points. Now, if this was a triangle, for example, where it's an actual shape, let's say that was the triangle right there, then you would know that you're stretching the triangle out that direction. Okay? That makes sense? You can also do this with any shape. Okay? The triangle could have extended only to this point right here. Maybe this was the triangle. Well, then you would have to make sure that that point connected as well, so that all the points connect. The reason why you have a point of dilation is to make sure that your figures, your image and pre-image, are similar. Okay? As we get more and more into geometry and shapes, we're going to be using more of our rulers and protractors and compass and different tools of geometry. So make sure you're used to and comfortable using them. All right. So our next vocabulary that we want to talk about is scale factor. Scale factor is the amount of dilation that you're going to use. Okay? And it's represented as a ratio. Okay? The length PQ over the length of your PQ prime. Generally, you'll see a scale factor is a whole number. Maybe a scale factor of 2, meaning your new image is going to be 2 times bigger. Or if you saw a scale factor of 1/2, then your image would be half that size. Okay? So that's your difference between scale factors. You can also have a negative scale factor. So if you had a scale factor of, example, 2, then the new image is 2 times bigger. And say you had 1/2, then the new image is half as big. Okay? But if you had an image, a scale factor of, say, -5, say you had -5, then yes, your new image is 5 times bigger, but there's an extra little thing in there, the negative. Anytime you have a negative scale factor, write this down. Any time you have a negative scale factor, which whenever you see scale factor in the book, they represent it with the variable k, by the way, for scale factor. Negative scale factor, the image is rotated 180 degrees and dilated. Okay? So not only would it be 5 times bigger, it would also be rotated on the coordinate plane 180 degrees. And remember, anytime you're doing rotation, you always go counterclockwise, because that's the way they numbered the quadrants. Why they numbered the quadrants that way, I don't know. I wasn't around when they did it. That's just what they are. Okay? So if your original image were right here, okay? Actually, let's draw a heart. I can draw that upside down. Or a tree. Let's go with a tree. There we go. Say that was your new image, or your first image. Your new image is going to be rotated 180 degrees and 5 times bigger. So it looks something like that. A whole lot bigger and now upside down. Okay? So that's with your rotation. Now, when you're actually constructing a figure and making it 2 times bigger, you're going to use a compass. This is a compass. Okay? Real cheap. You can get a dollar store, I think. But be careful. This one breaks apart real easy. So I'm going to actually stop this video and show you how to construct it on paper, and you can see how you would do that. But the basics of it are, if you have a triangle like this, connect all your points by extending them out, like so, okay? You know what? I went backwards. Because I ran out of room. So if you have your triangle here, and this is your point of dilation, because you've got to draw the bigger figure over there. Okay, so there's your point of dilation. Okay, and this center of dilation, if you're not given a point already, you can pick the point anywhere you want it. I could have put it here. I could have put it way out here. The whole purpose of the center of dilation is to make sure that all of your angles are exactly the same so that your figures end up similar. It's just a guide. It's not really important how far, how close it is to the triangle, as long as it's outside the triangle. And then notice I extended all my lines, and you should have used a ruler, but I did not. Okay? Then you take a compass, okay, and you would measure from the center of your dilation to the point. And then you can rotate it, your compass, and you make a little mark right there, which if I was using a dry erase marker would look like that. Okay? Then you're going to do the same thing with each point. Now, my compass isn't big enough to do this because it only goes to 6 inches. But I would do it here at this point. Okay. same thing. I'll try and get this as close as I can because they aren't quite big enough. So double. There, approximately. Okay? And that got you double because this was 1 length, 2 lengths, so it's a scale factor of 2. 1, 2. Then you connect your points, and I'm going to use a different color. I'm going to use a ruler. Like that. And like that. And now you have your triangle is 2 times bigger, with this being the center of your dilation.